Now I'm going to do Chapter 9, number 15. Based on data in Table 9.1, so you have to look back in the book, and the rule of 70, if U.S. per capita real GDP continues to grow at the average rate it has experienced since 1990, about how many years will be required for it to double? So if you look back in that table, just to get a number from the table, what you'll see is that the growth rate of the U.S. going back from when the book was published back to 1990 was 1.5. We know that the fourth quarter of 2019 was 1.9 on an annualized rate, which met the long-term rate of growth that I gave in my notes, and that was back to was it 1986? So there's a range here. It depends on which endpoints you choose, which long-term rate of growth we'll get. Which is why the rule of 70 or the rule of 72 isn't something that is designed to be used for very precise calculations. If you're thinking that and you're not sure which one to use, or you're confused by why there are two of these things that sound so similar, you're not seeing the forest from the trees. You're trying too hard. You're working at something too narrow. The idea here is just to have an easy way to see when something will double, something that's growing, when it will double. So if the growth rate is 1.5 and we use 70, which is the one I would use because the math is slightly easier, we're saying what goes into 70 1.5 times, because the way it works is the 70 will be the product of the rate times the number of years such that it's doubling. Well, if we know according to the start date the author chose and the end date of when the book was written, the growth rate then was 1.5. So we're wondering about the years. How long will it take to double? We're wondering about the years. So 70 divided by 1.5 is equal to, let me double check myself. When I first did this, I did it in my head, which is the idea. I didn't bother just now, I'm too tired. But I had noted, I first did this, I said roughly 45 years. And if you take one of these things, if you still have one of these things, and you say 70 divided by 1.5, you get 46 2/3, call it 47 years. Just under 47 years. Okay. So I did it in my head and got 45. I did it on my calculator, got 46.7. First of all, I might or might not be alive in 47 years. The practical use for me, of our GDP doubling, if I am alive, is pretty minimal. And since the time the author wrote this book, the estimate of 1.5 has ceased to be correct. Now a better estimate would probably be 1.9. So between now and roughly the time that I'm dead, that 1.5 or 1.9 is also subject to change. So this isn't meant to be something that you use to calculate precise returns on an investment. Take a finance class, there's plenty of tools you can use for that. This is something that's handy to get a feel for how long it takes for something to double. And it looks like this. If the information I had were a factor of 72, I would use 72. That's the idea, and that's the answer to 915. I hope you enjoyed it as much as I did.